Good evening, Steve. Huge thanks for joining us on what must be an incredibly hectic day there at JPL.
Oh, my pleasure. And I'm actually joining you from Denver because I'm with most of the science team. We've gathered here in Denver. A lot of people are already in town for a meeting, so this was a good place to get together during the flyby.
Excellent. Now, Jupiter is by far the largest planet in the solar system, but we know surprisingly little about it, don't we? So could you give viewers a kind of brief overview of the Juno mission?
Sure. My pleasure. Of course, one of my favorite subjects. Even though Jupiter is 300 times the mass of the Earth and more massive than all the other planets combined, and we've studied it for hundreds of years, we still don't know very much about what lies beneath the clouds at Jupiter. So we need to know some basic things like, is there a central core to Jupiter? We believe there's an ocean of liquid metallic hydrogen that generates Jupiter's enormous magnetic field, but details about the size of that ocean and whether there's a core in the middle and the motions of the liquid and so forth that generate that magnetic field still remain unknown to us. The basic structure of the interior of the planet is unknown to us. We see these belts and zones whipping around the planet. Almost all of that is the result of the fact that we can't really see beneath the clouds in the top of Jupiter's atmosphere. So Juno's job is to solve that problem for us. Our spacecraft is going to orbit Jupiter in a polar orbit, so it'll come over the poles of Jupiter, dive down underneath Jupiter's massive radiation belts, so between the radiation belts and the planet, and at the equator of the planet it will come very close to the planet, a few thousand kilometers above the cloud tops, and then go zipping off into orbit, 11-day orbit. So it'll take a couple hours to come flying by Jupiter, then be 11 days in a big long orbit around, and then come back again every 11 days for a year. In the meantime, with Jupiter rotating every 10 hours, by adjusting the timing just a little bit of each of those orbits, we can get a new longitude stripe. So we'll wind up making a map of the entire planet, and we'll use gravity, because gravity comes from the entire planet, to learn about the interior. One of the pieces of information you really need to know is how much water is there in the interior of Jupiter. So we'll measure that as well. From all of that, by learning about the inside of Jupiter, we hope to learn about the origin of the planet, which teaches us about how planets form, how solar systems form, and ultimately, of course, where do we come from?
You know, Steve, this is what fascinates me about astronomy and space exploration. Whenever we think we've learned something new, we find out actually that there's still this huge swathe of absolutely fundamental knowledge that we have no idea about. So I'm really looking forward to the results of the Juno mission.